Hello, Mr. Aaron, Mr. Ryan, right? Yeah? Okay, so let's say we have n persons from 1 to n, right? So 1, 2, 3, 4, up to n. And at the beginning, the first person has the pillow here. And it takes 1 second to pass the pillow from one person to another, to the neighbor, right? So at the beginning, the first person passed the pillows to second person, and in another second, the second person passed the pillows to the third person. And when the pillow reaches the nth person, and the next time you pass it back. So after t seconds, we want to know where the pillow is. Let's take an example at the 3 person, right? So Daddy, Ryan, Eric. 1, 2, 3. Daddy has the pillow. After 4 seconds, who has the pillow? After 4 seconds.
You.
1st second, 2nd second, the 3rd second, pass it back. The 4th second. Okay, after 4 seconds, Daddy has it. Right? And then the 5th second, 6th second, 7, 8, 9, 10, 11. N, this is the parameter N and T. We want to find out who has the pillows at the end. The N and T arbitrary, right? T could be a million. Okay, this is the hint. T could be a million.
If it's a number that many persons, like if you want to do a million seconds and then a million persons, it's the second last person.
Yes, okay. But N and T could be arbitrary. That's the thing. So how do we find out easily? I mean, obviously we can. What did Daddy just do? We can simulate, right? We can simulate the process. But this is not very efficient because T is a million and it takes million iteration. That's very slow, right? So any better ways to do it?
So you find out how many seconds does it take to take it all around back.
Okay, and then what's that? If there are 3 persons, how many seconds to go back? Travel? 4. Yeah?
Yeah.
1, 2, 3, 4. Yes. If there are another one, mommy is here. How many seconds? 4 persons. How many seconds?
6.
1, 2, 3, 4, 5, 6. Okay, so n, how many seconds to take a round trip?
N times 2 minus 2.
Okay, n times 2 minus 2. Okay, this is the same thing as n minus 1 times 2, right? N times 2 minus 2, okay? Okay, so we know the amount of seconds it takes to do a round trip, and then we are given t seconds. So what can we do about it? So do we need to, do these round trips? No, right? Because after a round trip, it doesn't change, right? Alright? So what do we do with this t?
Divided by the n times 2 minus 2 thing.
Divide it's modulus, right? We want to get a yeah, because we want to reduce this big number.
But if you get the integer and then you get the remainder, if the integer is an even number, then you can just easily just put it. But if it's an odd number, then it's still on the way back.
X modulus 39. How many possibilities? What's the possible values?
0 to 38.
39 values, right? So any number t modulus this one is this number of possibilities, alright? So we're reducing the t to n, right? Make sense? So after that, okay, so let's say t modulus n minus 1 times 2. This is k, okay? Suppose we have this number k. This is first person. After the round trips, there are k remain. So how many possibilities?
You add it onto the amount of persons.
Yeah, I know. It could be this way or it could be
This way.
Or the way back.
it could be here or it could be on the way back, right? So there are 2 possibilities. Either it's here or the way back. This bit is equals to n times 2 minus k. So we just have to get a minimum, right? It could be this way or this, whichever is minimum. For example, like 5 person, right? 1, 2, 3, 4, 5 person. K equals 4. Obviously, it's this one, right? K equals 8. K equals 4. This here. K equals 8. Which person is it?
Yeah, but if k equals 4, then it'll be 5. Because
okay. That's a plus 1. Yes.
That's why we subtract 2 because if you
Yeah,
if you
true.
get 1 second way back, this only gets 1 second.
True. Okay, so k equals this plus 1. Okay, I plus 1 here. Because when the remaining is start from 0, right? Remain is 0. I plus 1 to make it the first person. So let's say k equals 4. So obviously it's the fourth person. K equals 8. 1, 2, 3, 4, 5, 6, 7, 8 is here. Right? When k equals 8, you need to tell me it's 2. When k equals 4, you need to tell me it's 4. How do we get this 2 from 8? Is 5 times 2 minus 8. Okay. What it means is that we want to find out if it's closer to this side, yeah, to the left. Because if it's closer to the left, this k is closer to the left than it's this bit. It's on the way to the right. If it's closer to the left, the round trip, right? This k is bigger, then this portion is closer to the left. Am I right? Yes. Okay, so the answer will be just there, the minimum of these two.
But what if it's like going back?
This is the way to go back. Go back is this bit. Go back is this bit. We want to calculate this bit, right? To the left.
Yeah.
We want to find out who owns the pillow. Actually, is the left bit, right? Is this bit or this bit, right?
Let's say there's like 4 people and 7 seconds.
4 people and 7 seconds.
Yeah.
1, 2, 3, 4, 5, 6, 7.
Yeah.
Uh-huh.
I mean, like, how would you work it out? I'm not saying like.
Okay.
Formula.
4 person, n equals 4. How many seconds to travel around is total t is
8. No, 6.
6, right? 6. And then you say 7 seconds, right?
Yeah.
7 modulus 6 is 1, right?
Yeah.
1 and 1 needs to plus 1 because plus 1 to make it 2. Okay?
Yeah.
So 2, so we want to find out 2. There are 4 person. 4 times 2 minus 2. 2 and 6, which is smaller? 2. So it's the second person. Got it? Okay. Do you understand why we need to do the minimum of k and n times 2 minus k? Okay, so let me repeat, okay?
Is there any situation that it'll be the right side but n times 2 minus k?
Let's do this example again. Let's say how many seconds? Let's say
10.
10, yeah. 8, 9, 10, right? 10, okay? That's a good example. 10. So this bit is the same, right? So which bit is the same? T equals 6, n equals 4. N equals 4, t equals 6. The small t equals 10, right? 10 modulus 6 is 4. We need to plus 1, right? We want to find out 5 and n minus 2, n times 2, a minus 5 is 3, okay? So 5 and 3, that's 3. 7, 8, 9, 10, so 3. This is on the way back. This bit, or this bit, whichever is smaller. This is k, and this bit is n times 2 minus k. If this n minus 2 is k is smaller than this k, then it's on the way back. Otherwise, it's on the way to the right.
Yes.
Define f and t. So total round of t equals n minus 1 times 2, and t modulus equal t. And then we need to t plus equal 1, right? Modulus give the value start from 0. We need to plus 1 to make it the person, right? And then this t. So we just return minimum of t and n times 2 minus t, right? And let's say, what's the time complexity?
I1.
Okay, what's the space complexity? Do we use any additional? 1, yes. Arbitrary n and t, we can just calculate it almost immediately, right? Another one to solve it, if n and t is smaller. Okay, so let's say x equal at the beginning t, 4 underscore in range t, d equals 1, okay? And then x plus equals d. If x equal 1 or x equal n, d times equal minus 1, return x. X equals 1, d equals 1, range t times x plus equal d. If x equals 1 or x equals n, then d times minus 1. Okay, so return x. What does it do?
It checks if like it's going back or which way it's going.
So yeah, this simulation, right? Who owns the pillow after t second? Okay, then let's do this t second time. For each second, x plus equals d. T is the how much time? What's d? D equals 1, and then times equals minus 1 will be minus 1, and then times minus 1 will be 1, minus 1, 1, minus 1. What's this d thing?
It's like which way it's going, like if it's going like that.
Yeah, which way? So x plus d. If d is 1, it's going right. If d equals minus 1, going left, right? So when do we change the d? When we change the d? When the position is at the first person or the last person, we change the direction. And then after t round, and x is the person who holds the pillows, right? What's the time complexity for this one?
T.
OT, yes. We are talking about the time complexity, OT, yeah? It needs T iteration, okay? The space complexity. Any additional space? Constant space only, right? O1.
Yeah.
Okay, OT. Do you understand this OT now? Yeah?
Yes.
That's simulation, that's a math. So which one is better?
Left one.
Okay, left one. Okay, this is an exception, yeah? Today I talk about the optimum at the beginning, and this is to give you an example, okay? So why this is better than this one?
Is O1.
Because it won.
The computer just do this simulation, it takes time, right? If t is very big, like a million, then this takes a million iterations to n, right? OT, right? Yeah. But this one, if t is a million, it doesn't matter. Look, the second line, t modulus this, you immediately it'll become smaller value.
Yeah.
Okay. What have you learned today? That's it.
I learned about this people.
Yeah, people thing.
With
Okay.
a pillow.
Yeah. So what have you learned? I mean, what's the solution here? Can you tell me the problem and solution, and that's it.
So the problem is we have amount of people and we have amount of seconds, which is t, and so every second the person pass to the next person and to the next person, and at the end of the line the last person pass it back. And we want to find out what person does it end after finishing the t seconds. So we have the left one, which is basically like math. You just find out the n minus 1 times 2, and then we just modulus it and then give a remainder, and then you have to remember 2 plus 1, because when the first person pass it on the first second, it's on the second person, and you don't count the first person because nobody is passing to the first person on the first time.
Why this is minimum of t and n minus 2?
Because you might have a remainder which is larger than the amount of people, so it has to go back.
Yeah, go back, and we have to check which way is there. Right? Is it on the way or is it on the way back? Okay? Okay, that's it for today. Bye bye.
Bye.
Bye bye.